Okay. It's okay now. Thank you once again, Professor Paulo. So as Professor Paulo already explained, this first part of the presentation focuses on European initiatives at ports for the adoption of hydrogen-based energy. This work is divided into two parts. I will present the first part, and my colleague Danielle will present the second part. In this first part, we also divided the work into two phases. The first phase focusing on the initiative or initial screening of information that we searched from different sources and then cross-validating it with other sources to ensure that we report and we present the consistent information. The second phase focuses more on grouping this information using different parameters. So we're using a table where it uses multi-parameters to summarize the information. Overall, we found 177 hydrogen projects, and we eliminated 69 of them since we're not in partnership with the ports. And then out of this number, we found 27 initiatives in Atlantic area ports and 81 which were not located in the Atlantic area. We decided that we can include this information as well to our reports to compare the scale of the initiatives in terms of the complexity, the funding, and the location of the project. Regarding the parameters that we used, we have a production or the consumption. If there is a project producing hydrogen, we want to know how much of hydrogen is being produced. And for the consumption, how much is being distributed or being consumed. And we also have the parameter of the technology, whereby we look at which technologies are used to produce the energy carrier, whether electrolysis, carbon capture, storage method. And then we also have the final uses of the energy that will be produced. In terms of dissemination, we prepared several documents that you can find on our website. One of them being the deliverable 4.1.1, which focuses more on mapping of initiatives for hydrogen growth in the Atlantic area. In this document, we include all the parameters that I mentioned, and we explain the methodology of finding the information and how we selected this project. And then we give you the files or the projects that we found by listing them using the parameters that I already mentioned. At the end of the document, you can find a list of hydrogen initiatives, all from the Atlantic area and those which are not in the Atlantic area ports. We also prepared developed an interactive map of hydrogen initiatives. On this map, we summarize the information from the report that we prepared. But we also include important parameter, which is the status of the project, whether the project is ongoing, or it's cancelled, or is completed. Now let's talk numbers based on the information that we found. On this map, you can see the number of seaports in the Atlantic areas. And you can also see the number of ports that are in partnership with hydrogen initiatives. At the moment, we have Spain leading in terms of number of ports that are in partnership with hydrogen initiatives. But when we look at the number of hydrogen initiatives, we have France leading. This is due to the fact that we can have one port having several hydrogen initiatives. Moreover, we summarized the information that we collected in terms of energy sources, the types of technologies used, the types of energy carriers, and the final uses. And we noticed that since most of the projects are focused more on the green hydrogen production, the most used energy source is solar and wind, and the technology that is used is the electrolysis. In terms of the final use, we categorized this information in terms of storage, and marine mobility, non-marine mobility, port-to-port transportation, storage, and distribution, industrial, and if the energy that will be produced will be used to generate electricity as well. In terms of timeline, we have a project started since 2015, and most of them will complete in 2030. And the budget ranges between 750,000 euros to over 1 billion euros. Regarding the carbon emission reduction, we have numbers ranging from 500 tons to 1.2 million tons of reduction. To summarize and conclude this presentation, here I provided a list of key European initiatives, mostly focusing on the northern part of Europe. You can see here we have the Netherlands leading and Germany follows suit. For France, Spain, Portugal, and Ireland, here I am reporting not only the numbers related to Atlantic area ports, but all ports in the country that are in partnership with hydrogen initiatives. The table that you see gives sense to the numbers that we found, showing that in terms of industrial area, logistics and transportation, the amount of liquid bulk and dry bulk and bunkering, we have Netherlands having more area or the capacity to host this hydrogen initiatives. And now I think I will pass it to my colleague, Daniel, if he's already here. And thank you so much for your attention.
Well, thank you very much. It was actually fortunate that I got to go right after Dr. Lopus, because there's actually some synergies with regards to what he said and the presentation that I'm going to put forward. Still, just to highlight a little bit what I'm going to talk about, the presentation will focus on EU targets and market trends, European initiatives, and also Atlantic area initiatives that we identified throughout the HYDEA project thus far, as well as some contributions of the project. So starting with some general EU targets and market trends, if you search in the European Commission website, notice that we have some rather ambitious objectives that are being updated every now and then. For example, for renewable energy as a whole, we're looking at about 45% integration by 2030, including the role of marine renewables. So, for example, offshore wind, wave energy, so on and so forth, going from 1 gigawatt in 2030 to 40 gigawatts in 2050. In terms of hydrogen, we're looking at about 10 million tons of renewable H2 production by 2030, allied with, of course, 40 gigawatts of installed electrolyzer capacity. So rather ambitious projects put forth by the European Commission in particular, within the scope of the EU area as well. For shipping, this was already addressed in a way before, but it will be the main guideline is the ETS allowances, namely the necessity to surrender about 40 to 100% of the emissions from the shipping sector between 2025 and 2037 in terms of allowances for CO2, CH4s, and other pollutants, for example, SOx and NOx, so on and so forth. So it will be very important to make this transition, as Ugo was also stating, in terms of decarbonize the ships, because the ships are a major source of emissions, and that's crucial in terms of the context of combating climate change. So you may wonder about inclusion of renewables, because in truth, all these fuels, hydrogen, methanol, ammonia, they don't appear out of thin air. They require energy from the get-go. They work more, I would say, as a storage system. So, and for that, you need energy. And an interesting source of energy, or a set of energy sources for decarbonization, are especially renewables, which have a very high potential. I'm from Portugal, and I can tell you that the integration of renewables, for example, in our electricity grid is quite high so far, and it shows that there's a lot of energy to be, let's say, harnessed. But there's the issue of intermittency, and this idea of employing energy carriers such as methanol, hydrogen can be very useful, especially within the scope of energy transition at ports. And you can see that concept a little bit here on this schematic as we go from, let's say, the production stage of renewable energy up until the final end uses, well, either within seaports or outside of seaports. And there's also some trends in terms of the establishment of hydrogen hubs, valleys, corridors, with several projects that I'm going to slightly address, for example, the H2-Med project. And a major issue here that also complements this transition is the fact that over 95% of H2 right now, and by, let's say, consequence, the derivatives, is not green. It comes from the steam reforming of natural gas. So incorporating further renewables is extremely important at this stage to ensure that we don't enter into one of those situations where you have, let's say, a car that is supposed to be electric, but then you get the electricity from, for example, a diesel generator. Okay, so we're trying to make something that is consistent with the energy transition right now. Other trends that you'll see here, as Hugo was pointing out, is, let's say, the dominance still of conventional oil bunkers, but also the increased market share being taken by LNG in particular, but also by methanol and other fuels. In the case of LNG, like Hugo was saying very well, there's an uptake recently, and this is followed more or less by methanol, with over 200 vessels right now, as you see in this statistic, about 310 being on the order books. And according to the DNV's AFI platform, by mid-2025, we had an increment of these order books, so adding to what existed before, of about 87 LNG, 40 methanol, 4 hydrogen, and 3 ammonia vessels. So you see here that in the short term, I would say we can expect LNG and methanol to sort of dominate, while hydrogen and ammonia will require some more developments and consolidation before gaining leverage. So maybe a longer term solution. There's also some discussion still in terms of what will be the prevalent electrolyzer technologies, although the market trends point towards alkaline and proton exchange membranes being prevalent. There are, although, other alternatives that are being developed, such as solid states, AAM, so on and so forth. But this is a major issue, which is to define what are going to be the trends, the main market decisions that uptake the sector. And this is something that will be further discussed in a little bit, okay? For now, let's just take a quick look at European initiatives as a follow-up to what my colleague Lawrence was showing. So, as I said, at the European level, we're establishing several initiatives, either within the context of hubs, valleys, corridors. For example, on the left, you can see a very important corridor, the H2-Med corridors, that are being established within the framework of the European landscape. And you see that they range from, for example, the H2-Med south that connects Portugal and Spain up until the area of the North Sea, where you see, for example, H2 Hercules network that connect to the hinterlands of both France, Germany, and other Nordic countries. You can also see on the right-hand side a quick presentation related to the H2 ships platform that is being promoted by the Port of Amsterdam. There's also other interesting, let's say, information sources that you can look into to take a broader analysis of the European initiative. For For example, Dr. Hugo was showing very interestingly the Methanol Institute web platform. While here you can also see a complementary platform, which is the hydrogen infrastructure map, which showcases numerous initiatives across the European landscape, both within the context of seaports and also just initiatives in general. And you can also see some details about another group of initiatives, namely more in the area of Germany and surrounding countries related to the Rhine initiative. So it's like a big initiative with smaller projects related to it that are trying to establish a network. So a pattern that we're seeing here is this sort of connection, a bit like let's say the circulatory system of a human body trying to be established within the European landscape in order to connect the different countries and the different landscapes to promote that incorporation of hydrogen and hydrogen-based energy carriers into our economy and into our industries for that energy transition. So it's a process that, as you can see, is extremely complex and has different realities because in some places people invest more in wind, in others in solar, some will invest in alkaline electrolyzers, other in PEM electrolyzers. Some projects will probably focus on methanol, others in hydrogen. And I want to stress this: there may be here a little bit here the risk of, let's say, noise or the lack of synergies, because there's a lot going on, there may be a risk where we don't explore fully the potential of these connections because they may be divergent from one another in terms of the realities of the projects. Okay, this will be more evident now when I talk about the Atlantic area initiatives. For example, looking at France and Ireland, here we have a more detailed summary of what my colleague Lawrence presented about the initiatives that we have going on in the Atlantic area. Okay, as you can see, we have different numbers of initiatives depending on the landscapes, with different timelines and rather variable actors and also investments. You will notice, however, that renewable energies, mainly wind and solar, are somewhat prevalent, but there are other opportunities being explored, for example, from biomass, biomethane, and other renewables. Okay, there's also a strong emphasis on electrolyzer, although sometimes they are combined with carbon capture and utilization systems, and also biomethane. In terms of final energy carriers, interestingly, there seems to be a lot of emphasis in projects that involve H2 in detriment of methanol and also ammonia. And you may think, oh, this is somewhat contradictory to what we saw before because methanol was prevalent. What happens is that these are, I would say, projects for demonstration, and that sometimes by consequence they lead up to other energy carriers. For example, maybe you have a project that is based on methanol or ammonia, but you need also to involve hydrogen into the process. Okay, because in the end they are all they always involve hydrogen into the mix one way or the other. Okay, you'll notice also that most of the projects are what we call green, so that the energy source comes from renewable sources. Okay, for the final energy carrier. Still, some of these projects are of a limited scale in the sense of, for example, you saw the order books for shipping. Those order books were for vessels and for major groups like Maersk. In this case, we're looking maybe a little bit more into projects that can go from the exploratory range into the establishment of some demonstration units or some demonstration projects. In some cases, for example, like Hugo was showcasing, there was a big integration into the seaport, in this case, the port of Lake Strange, but the realities can vary quite a bit in this context, which is not necessarily the best outtake. There's also quite variable energy carrier production goals. As you can see, for example, in France, we can go up to a few thousand kilotons of hydrogen per year, up until 50,000 tons. And sometimes there's also not fully available information from the projects. There are sometimes also reduction of emissions. For example, in the case of France, sometimes they refer about 500 tons per year of emissions that are reduced. But again, there's not always this information available, which also makes it difficult to fully characterize the market trends. Here we do notice that there's quite a significant investment, I would say, or derivation into mobility, namely projects that focus on decarbonizing marine mobility, also industry, sometimes internal electrification of the seaports, and also distribution to the hinterland. In some particular cases, namely those that involve ammonia, we see the potential use of ammonia as a fertilizer later on the process. Okay, so there's a lot of synergies here that can be complemented either from industry, storage within the seaport, distribution for other uses, decarbonization of marine mobility. But the realities vary a little bit because there's a lot of dispersion within the projects. Okay. In the case of Spain and Portugal, we actually have some interesting outcomes as well going on, between 7 and 8 initiatives for each country, with rather significant investments also being involved. Some rather large ones. For example, in Spain, there's one that goes over 1 billion euros, and it has a lot of external entities being involved. While in Portugal, we also have a lot of partners being established. For example, university like Porto, seaport authorities like APDL and APS, energy companies like EDP, GAP, so on and so forth. So a rather, let's say, busy landscape in the Iberian Peninsula too. You will also notice that we are leveraging a lot on solar and wind, which are major renewable energy sources that are being invested on in the Iberian Peninsula, given our access to those resources. And this will be complemented, hopefully in the future, by offshore renewables, for example, offshore wind, wave energy. You will also notice that we continue to follow the patterns of electrolyzers being somewhat prevalent, namely PM and alkaline, although we start to see also some alternative solutions. For example, within the HYDEA project and H2-driven, there are technologies that our colleagues in the chemistry department are developing, from new membrane systems to new carbon capture technologies. And there's also some interesting applications for some interesting technologies that we see in particular projects, like, for example, the use of recycled wastewater. You'll also notice that, again, there's a lot of presence of hydrogen-based projects, but as you saw from the example of APDL, there's also a strong investment in methanol. So if you look at the Iberian Peninsula, it's actually a bit deceiving because you have a rather significant investment in methanol projects, even though it seems here that there's hydrogen in the mix. It's also present there, but in a lot of instances, let's say the main initiatives are focused in the methanol, as also who was highlighting before. In terms of applications and some targets that we want to look on, they also vary a little bit. They are usually in the hundreds to thousands of kilotons of H2 per year, while you also have some uptake in terms of methanol production and even ammonia in some instances. The reduction of emissions can be quite interesting. For example, in the case of Spain, we can go up to 1 megaton per year, while in Portugal, we are looking at values up until 1.2 megatons per year. While in terms of initiatives, the main applications and services still focus on, again, some storage, mobility, both marine and non-marine mobility, punctual agriculture applications, and a lot of industry, internal electrification processes, and also distribution for a lot of usage. Okay, there's also some establishments between port-to-port transport. For example, in Portugal, we are leveraging a lot connections in terms of port-to-port transport, so marine transport of energy carriers, for example, to the port of Amsterdam and other ports in the Nordic region, I would say. So this is the framework, I would say, and just to highlight, thus far, within this context, HYDEA has strived to achieve a lot of objectives, namely identify key opportunities from emission reduction, climate change mitigation, conjugation with carbon capture, storage, electrification of ships, so on and so forth. But there's a lot of bottlenecks that we also identify that need to be tackled, maybe technical, economic, social, environment, and legislative. So these are, let's say, what's preventing us from moving forward and to establish the, let's say, a truly European and consolidated market. And so we have a lot of questions to ask. Which energy sources should we consider? Wave, solar, wind, hydropower. Which will be the energy carriers? Will it be methanol, ammonia? What type of electrolyzers? What type of port models? are we going to follow? We have to decide this and use the Atlantic area as a successful case study region based on what we know from other projects and also what we learn throughout the HYDEA projects. And in this case, because we have a lot of projects going on in the European landscape, as you saw, we have a lot of good and bad experiences that we can learn from. Okay, so this is like an overall brief. I'm not going to go too much into detail about the project as a whole. Professor Paulo has kindly explained some of these contributions already so far, but I just want to leave you with this image on the right-hand side of what we want to see as a whole, the establishment of this framework at an European level, going from the marine renewable energy or even other renewable energies on shore up until the final distribution and utilization of the energy carriage. This is our dream, and hopefully we'll be able to achieve it. And we also hope to see you all join the HYDEA community and leverage further on the results of this project. With that, I conclude my presentation and leave it to you if you have any questions to be clarified. Thank you very much.